Today, shall take types of electrodes. Today's topic that deals with the types of electrodes. Mainly, there are six types of electrodes are observed. Okay, six types of electrodes. Okay, there are total six types of electrodes are observed. Okay, the first category of this electrode you already studied one, that is what we call it as metal ion electrodes. Okay, metal ion electrodes. I put one diagram here. So here this is a one metal, say M metal, and this metal it should be dipped in a Mn plus solution. Okay, a metal M is dipped in a solution Mn plus. Okay, and that type of electrodes are called it as a metal ion electrode. That is nothing but an electrode. That means that an electrode this type, and write it like here, this type consists of a metal hmm, dipped in a solution containing its own ions. Okay, you take M metal, and that metal should be dipped in a solution containing its own ion, like Mn plus ions. Okay, M should be dipped in a Mn plus ions. And how we represent this electrode? See, how we represent this electrode? Okay, see, this is simple. Like in case of Daniel cell, you already represented a copper electrode and zinc electrodes, etc. Okay. Mm, Here, the representation I'll take. Okay. Represent. I'll take simple one. Okay. Zinc electrode. Zinc. Okay. That is dipped in a Zn2 plus solution, or Cu dipped in a Cu2 plus solution. Okay, so this is an example for metal ion electrode. And the reaction, electrode reaction in a metal ion uh, electrode is zinc, okay, ion, and take a reduction reaction gives zinc, takes to electrode may act as anode or cathode depending upon the other electrode. Okay, this you already observed in while solving a problem. Like if you take a zinc, couple zinc with the copper, so that time this electrode act as anode, yeah, and copper act as a cathode. If you couple a copper with silver, okay, Ag plus, then Ag act as cathode and silver act as anode. Depending upon the other electrode, one the said electrode acts either it may act as anode or cathode. This is the first type of electrode, metal ion electrode. An electrode consists of a metal dipped in a solution containing its own ion. Now I'll take the second type of electrode. Okay, the second type of electrode, what we call it as metal, hmm, metal salt ion electrode. Metal salt ion electrode. It's also called as, or may express it as metal insoluble salt ion electrode. Metal insoluble salt ion electrode. A metal insoluble salt ion electrode. Here, this electrode consists of a metal, okay, consists of metal, is in contact with with a solution of sparingly soluble soluble salt of the same metal, sparingly soluble salt of the same metal, okay, containing an ion of the salt. I'll take one example, like a calomel. A good example is a calomel electrode. In the calomel electrode, a mercury is present, which is in contact with the mercurous chloride. This mercurous chloride is a sparingly soluble salt. That means a metal mercury is in contact with a sparingly soluble salt of the same metal containing anion of the salt. Okay, here anion of the salt it contains. Or even the another electrode is Ag bar AgCl bar Cl minus. Okay, silver chloride electrode. Here silver chloride is a sparingly soluble salt. In the silver chloride electrode, will take a silver metal that is dipped in a AgCl solution, which contain a little quantity of AgNO3. So it forms a sparingly soluble. Some precipitation are present in that mixture or in the solution or in the electrolyte, and that type of electrodes are called as a metal salt ion electrode. That is metal insoluble salt ion electrode or a metal salt ion electrode. Here a metal is in contact with a solution of a sparingly soluble salt of the same metal dipped in a solution containing anion of the salt. Here a mercury is placed at the bottom and which is in contact with a sparingly soluble mercurous chloride. In turn, it is covered with the electrolyte KCl. Okay, and to make an external electrical contact, a platinum wire is immersed, and this electrode, what we call it as a calomel electrode, and this electrode may act as anode or cathode. So that's why this electrode also called as a reference electrode. It is called as a reference electrode. Okay, this is an example for reference electrode. Okay, even the metal ion electrode also called as a reference electrode. Even metal salt ion called as a reference. It can be used as a standard reference while measuring the electrode potential of other electrode. Okay, the second type of electrode is a metal salt ion electrode. What the basic difference between first one and second one? In the first one, we use a metal which is dipped in a metal ion solution. Here, a metal is dipped in a sparingly soluble salt of the same metal containing anion of the salt. And the third type of electrode, this you already studied in your PO. The third type of electrode, that is what we called it as a gas electrode, called as gas electrode. Okay, a gas electrode consists of, that's a good example for gas electrode is a hydrogen electrode. The hydrogen electrode is a gas electrode. So how we represent the gas electrode? The hydrogen electrode, platinum is in contact with H2 gas and in turn it contact with H plus ion. Yeah, that means here we use a gas molecule. That means you know very well. 1 atmosphere, under 1 atmosphere pressure, you introduce a hydrogen gas bubbles. On the surface of the inert metal, a gas molecule is in contact with the ions of the solution containing ions of the gas molecule, like H2 gas is in contact with the H plus ions. So, and this the variation in the phase, in turn, an electrical double layer is developed as a result and establishes a equilibrium between the gas molecule and the ions, and the potential is again picked up by an inert metal platinum. Okay, so in turns, the gas electrode we may considered as it consists of a bubbles gas bubbles is in contact with an inert metal wire, where it is present, it is immersed in solution containing ions of the gas molecules, The metal provides, which one is a metal? That is a platinum, provides an electrical contact and facilitates the establishment of equilibrium equilibrium between the gas molecule, between the gas and its ions. There exists an equilibrium between H2 and H plus ions, okay, and there is an equilibrium between these two, and again the potential is picked up by a platinum electrode. The good example for gas electrode is a hydrogen electrode, okay, and even the chlorine electrode. And you know the reaction that taking place in a hydrogen like a electrode, that is H plus ion takes electron and giving H, and two H molecules combines forming H2 gas liberation, okay. This is a third type of electrode, called it as a gas electrode. In the gas electrode, one of the component used is a gas molecules. That's why the electrode we called it as a gas electrode. It consists of a gas molecules which is bubble on the inert surface, which make in contact with an electrolyte of the same gas molecules, okay, electrolyte of the gas molecules containing ions of the gas molecules. Like if you take another gas electrode like a chlorine electrode, there we use chlorine electrode. We may observe this type of glass electrode. There platinum, over that we introduce a chlorine gas and makes a contact with the chloride ions, and the potential is picked up by an inert metal platinum, okay. And the fourth type of electrode, what we called it as a redox electrode, or it is called as a oxidation reduction electrode, okay. Oxidation reduction electrode is a fourth type, or it is simply called as redox electrode, okay. It's a redox electrode. It's like a simple a platinum wire is inserted in the electrode. A platinum wire is inserted, okay, and in a solution containing, or solution which can able to show variable in the oxidation state. Like we may introduce a platinum is introduced, wire is introduced to a ferrous ammonium sulfate solution, and this ferrous ammonium sulfate solution contains Fe2 plus ions. To this, if you add K2Cr2O7, you know it is an oxidizing agent. FAS is a reducing agent. A redox reaction take place. This is an oxidizing agent. K2Cr2O7 is an oxidizing agent. FAS is a reducing agent. A redox reaction take place. That time Fe2 plus changes to Fe3 plus when you add Cr plus 6 ions. A redox reaction take place. Yeah, as soon as Cr plus 6 is introduced, the number of the electron is get oxidized. Fe2 plus get oxidized to Fe3 plus. At the same time, Cr plus 6 reduced to Cr3 plus. A redox reaction take place. Okay, and this change in the variable in the oxidation state, or the potential arises from the tendency of one form changes into another form, and this change in concentration of Fe2 plus with that of Fe3 plus is picked up by a platinum wire, a inert platinum wire, and it shows the change in the potential, or it shows some potential, and that potential what we called it as a redox potential. So that's why these electrodes are represented this way. A platinum wire is in contact with the ions like Fe2 plus and Fe3 plus, okay, or platinum contact with the cesium. It also shows a 3 oxidation state, cesium 4 and cesium 3, or platinum is in contact with the SN2 plus and SN4 plus, okay. So these are the different oxidation state we observed, and that's why because of the variation in the oxidation state by the addition of redox or oxidation or a reducing agent, we observe a change in the concentration. In turn, it shows some potential, and that potential is picked up by a platinum electrode, and that electrode, what we called it as a redox electrode. Okay, or in other words, we can write it as an oxidation reduction electrode is one in which the electrode potential arises from the presence of or by the presence of oxy by the presence of oxidized and reduced forms of the same substance in a solution. Okay, then the potential developed is picked up by an nut electrode like platinum. Okay, so we can represent this electrode this way. Platinum is in, it's due to change in oxidation state. We can observe a potential, and this type of electrode, what we called it as a redox electrode. Here, the platinum is an inert metal. It will not undergo oxidation or reduction reaction, but the ions which present in the electrolyte, they undergo oxidation or the reduction species depending upon the other added electrolyte. So it shows a change in potential, and that potential, what we called it as a redox potential. Okay, or redox electrode, called it as a redox electrode. I'll take the fifth type of electrode. The fifth type of electrode, what we call it as amalgam electrode. Metal, even it is called it as a metal amalgam electrode or amalgam electrode. Fifth type of electrode is a metal amalgam electrode. Okay, this electrode is similar to that of metal ion electrode. It almost resembles with the metal ion electrode. How we represent metal ion electrode? Like lead lead is in contact with lead ion. Yeah, this is a metal ion electrode. Yeah, metal ion electrode representation. Okay, so for in the case of amalgam electrode, instead of using metal, we use metal amalgam. It is a metal is coated by means of a mercury, and that is dipped in a metal ion solution. This is an example for a metal amalgam electrode. Okay, then how we define a metal amalgam electrode or a metal amalgam? Okay, a metal amalgam is in contact with which ion? With a solution containing its own ion. Here we can get a very few type of metal amalgam electrode. That means the metal can able to hold amalgam, those electrodes, and it is stable over a temperature. Then only we can produce a metal amalgam electrode. The good example for metal amalgam electrode is a lead amalgam electrode. Here, a metal amalgam is in contact with the electrolyte solution containing its own ion. Okay, and the sixth type of electrode, what we called it as ion selective electrode, called as ion selective electrodes, and it's also called as membrane electrode. Also called as membrane. It's also called as membrane electrode. Metal ion selective electrode called as membrane electrode. Okay. See, the good example for membrane electrode is glass electrode. You can observe a bulb. This is what we call it as a glass bulb, sensing bulb. This bulb can able to exchange a particular ion, or it can act as a membrane between internal solution with that of outer solution. And this electrode usually we dip in a solution whose electrolyte concentration is to be determined. Like if you want to detect H plus ion concentration, the electrode is dipped in this. Along with this, we have to dip another electrode, like even a zinc electrode, any other type of electrode, and these two electrodes are connected by means of a salt bridge. Okay, thereby we can construct a cell and we can able to get some EMF. Based on that EMF, we can able to detect the electrolyte concentration. Okay, so here then what is ion selective electron? It is a membrane electrode. Here a membrane is in contact with the solution with which it can exchange their ions. Okay, in case of ion selective electrode, here we can write it like this: a membrane, it may be a glass membrane. Okay, a membrane is in contact with a solution. Is it? It contact with the solution. What kind of solution? With which it can exchange their ions. So this membrane can able to exchange a particular type of ion. It is a selective ion and is specific to a particular ions. Okay, a membrane is in contact with the solution with which it can exchange their ions. Here, the membrane, glass membrane, with that will take a HCl solution of particular normality. And this H plus ion interact with this H ion. So there is a development of electrical double layer. So a potential is developed. Okay, and that type of electrode, what we called it as a ion selective electrode. Particularly the glass electrode can able to exchange H plus ion. Okay, glass electrode exchange H plus ion. Now I comes to types of electrode. What we called it as a reference electrode. These electrodes can be used as a standard reference while measuring the other electrode. I already discussed the 6 type of electrode. All these 6 type of electrode can be used as a reference electrode. So the reference electrodes are the electrode with reference to those the electrode potential of any other electrode can be measured. How we define? The reference electrodes are the electrode with with reference to those the electrode potential with reference to those electrode, the electrode potential of any other electrode, potential can be measured. The type of electrode all called as a reference electrode. Here are the reference electrode are the electrode with reference to those, the electrode potential of any other electrode potential can be measured. Okay. So it can also, this reference electrode can also act as anode as well as cathode depending upon the nature of the other electrode. That means it is not a restricted. This electrode should act as anode or this electrode, ion selective electrode should act as cathode. It's not restricted. It depends upon the other electrode. Based on the other electrode potential, the reference electrode act as anode as well as a cathode. There are two types we classify the reference. This electrode again comes under two classification: primary reference electrode and the secondary reference electrode. Primary reference electrode and secondary reference electrode. There are two types: primary reference electrode and the secondary reference electrode. The primary reference electrode is the one in which the electrode potential is arbitrarily fixed to zero. That is only one electrode, that is hydrogen electrode, comes under primary reference electrode. All other type of electrode comes under secondary reference electrode, like metal ion, metal salt ion, ion selective electrode, redox electrode, they all comes under secondary reference electrode. So calomel electrode, they all comes under a secondary reference electrode. This is about reference electrode. Reference electrode are the electrode with reference to those the electrode potential of any other electrode potential can be measured. Okay.